Hello, welcome to ANS Solver. This is the sixth question of the paper. So by differentiating cos x over sin x, show that y equals to cot x is dy by dx equals to minus cos x square x. So I know my y is basically equal to cos x over sin x, correct? Because that's basically cos x, cot x, sorry. So I use something called as the quotient rule to differentiate. Because cos x is divided by sin x. So I take my numerator, which is cos x, as u, and I take my denominator as v. So I take my u dash, which is basically the differentiation of cos x, which the differentiation of cos x is simple, minus sin x, and v dash, which is the differentiation of sin x, which is cos x. Now I use the formula, which is vu dash minus uv dash over v square. So I can simply use vu dash, which is minus sine square x, correct? And minus uv dash, which is minus cos square x, over v square, which is sine square x. So I can simply take minus common here to write this as sine square x plus cos square x over sine square x. Now sine square x plus cos square x I know is 1. So I can write this as minus 1 over sine square x. Now I know cosec x is equal to 1 over sine x. So 1 over sine square x can be written as cosec square x, which is what I needed to prove. Okay? Now I need to integrate this. Now, for this, I'll use something called as ILATE, because this is integration by parts. I basically means inverse, L means logs, A means algebra, T means trigo, and E means exponents. If you see x here, basically is algebra, and cos x square x is trigo. Okay, so I can simply say now that my u here, okay, is x because a comes before t, and my v dash is cosec square x, correct, because t comes after a. So my u dash is simply the differentiation of x, which is 1, and v is the integration of cosec square x. Now we saw in the previous part here the integration of the differentiation of cot x was minus cosec square x. You know that integration and differentiation work in reverse ways. So I can simply say the integration of positive cosec square x is negative cot x, correct? So I can simply say this here is negative cot x. So now what I can say is, I can simply say my formula, which is uv minus integration of vu dash. So u into v is basically x or minus x cot x, which can be written as cos x over sin x with the limits, which is basically 1 upon 4 pi and 1 over 2 pi. Okay? Minus 1 over 2 pi and 1 over 4 pi, and vu dash. Vu dash is simply minus cot x dx. Now finally I can write this as minus x cos x by sin x with the limits 1 over 4 pi and 1 over 2 pi, plus, because here the minus and minus can become plus the integration of 1 over 4 pi and 1 over 2 pi, and cot x can basically be written as cos x over sin x dx. Now I always tell you, split this into parts. That means split it something like this. Now let's look at this first. First, put in the place of cos x and sin x 1 over 2 pi. Okay, just do that much. When you do cos of 1, and make sure you are on the radian mode. So when you do the cos of 1 over 2 pi, okay, you simply get 0. That means this full thing becomes 0. Now, what you do is put cos of 1 over 4 pi. When you do that, you get 1 over root 2. And when you do sine over 1 over 4 pi, you get 1 over root 2. So you can simply write this as minus of 1 over 2 pi, which is, 1 over 4 pi. Sorry, this is a problem. 1 second. Minus 1 over 4 pi. Now what I can do is simply I can do cos of 1 over 4 pi, okay, over sine of 1 over 4 pi, which will give me 1. So I can just simply write this as 1 over 4 pi. Okay, basic limit substitution. Now let's focus on this, the other part. How do I integrate cos x over sin x? I can't use by parts, I can't use partial fractions. The only thing I can use is integration by substitution. So here I take my u as sin x. So I get my du by dx, basically the differentiation of sin x, which is cos x. So I get this as du by cos x equals to dx. So now without the limits, because I'm writing in the terms of u, I can write this as cos x over u du over cos x. Instead of dx, you can just write du by cos x. I can simply cut cos x here. So I get the integration of 1 over u du. So now the integration of 1 over u is simply ln u. Okay. Now I know u is simply sin x. So this is ln sin x with the limits 1 over 4 pi and 1 over 2 pi. So now what I can simply do is I can first substitute 1 over 2 pi in the place of x. So when I do sine of 1 over 2 pi, I get my answer as 1. That means this is ln 1 minus, now put sine of 1 over 4 pi, which I know is 1 over 2. 1 over root 2, sorry. So I get 1 over root 2 here. Okay. Now I know ln 1 is simply 0. So I just get ln 1 over root 2 minus of ln 1 over root 2. So now what I simply do is I write everything together. So I can write this basically as 1 over 4 pi minus ln 1 over root 2. Now what do I need to prove? I need to prove this. Correct? So now what I can do is I can basically I can write this as 1 over 4 pi minus ln of, I know this is basically, I can write this as 2 raised to minus half. Agreed? Because this is basically 2 raised to half. And when I take 2 raised to half in the numerator, I can write this as 2 raised to minus half. So now a log property comes here into play, which is basically log a raised to b can be written as b log a. Got it? So I can simply write this as 1 over 4 pi minus of minus 1 over 2 ln 2. So I can write this as 1 over 4 pi plus 1 over 2 ln 2. Okay. So now what are they doing? I need this, exactly this. So if I take 1 over 4 common, so I get pi, okay, plus here I know I'll get 2, correct? Obviously 2 ln 2. Agreed? Because now when I take 1 over 4 pi, 1 over 4 inside, I need to get this again. Now using this property again, I can simply write this as 1 over 4 with pi plus ln 2 square, which can basically be written as 1 over 4 pi plus ln 4, which is basically the final answer of my question. Go through the steps again if you didn't understand. Listen to the explanation. But yeah, it's an easy sum to solve.